today we're talking about resolving forces. Still on the same topic, forces and motion. Resolving forces. Acha. So far, what we've studied is like, let's say this is a car. Okay. And we've studied forward forces, right? And we've studied backward forces. And we know that forward force minus backward force equals ma. So far, our forward force and the backward force have been horizontal forces. Both of them have been horizontal forces. Now what will happen is that you might get a force that is not acting horizontally to the car or whatever this object is, but it might be acting at a particular angle from the horizontal. For example, this force is acting at an angle of 20 degrees from the horizontal. And let's say there's a backward force as well, which is horizontal. So now you can't call this your forward force. The reason is that this needs to be aligned with the other forces. So this is horizontal. So you need a horizontal component. Similarly, weight is acting in this direction, right? And if there's a contact with floor, which there's going to be a normal contact force acting in this direction. It makes a 90-degree angle with the contact. So there's a normal contact force in this direction. It's usually referred as R. So moving forward, we'll be writing R in place of normal contact force. Now, you again cannot consider this as a vertical force because it's not aligned with R and mg. So instead, you'll need its vertical component. So you'll need this component of the force acting at 20 degree. So what you need to do, you need to break this this force acting at 20 degree into two components, a horizontal component and a vertical component. And you'll be using the vertical horizontal component along with the other horizontal component and the vertical components along with the other two vertical components. This is a vertical component, this is a vertical component, and this is a vertical component. So if ever in a question you have a force which is not horizontal, you have to break it into a horizontal part and a vertical part. Now, how is this done? Let's say this is a force of 20 to already degrees. Let's say this is a 30 Newton tension in the string that's pulling the object. So now you'll have to resolve this 30 newtons into a vertical component and a horizontal component. So you can make this into a right angle triangle and use SOHCAHTOA. So I'm going to use 30, 20 degrees, a 90-degree angle. Okay. I'm calling the vertical component Y, the horizontal component X. Okay. Also, you need to know the direction of the components. If this vector is pointing in the direction I've shown, then its horizontal component needs to go right and its vertical component needs to go up because this force is going right and up. That's why the horizontal component needs to point right and the vertical component needs to point up. So we've shown the directions. Now let's break down the components. So for Y, I can use SOH, or some people have. So sine 20 equals opposite Y over hypotenuse 30. So y is going to be 30 sine 20. So this is 30 sine 20. And to find x, I'll use cos theta is equals to adjacent over hypotenuse, or curly brown hair base over hypotenuse. Okay, so x would be 30 cos theta. So this is 30 cos theta. So what you need to remember is the opposite line, this one is opposite, this line is opposite to the theta, so this will be the sine component. And this one, the adjacent one, is always going to be the cos component. Okay, let me give you another example. Here's a force acting in this direction. Let's say it's a 50 Newton force, and it's making an angle of 25 degree with the horizontal. Now you need to break it down into a vertical component and a horizontal component. The horizontal component must point towards the left, and the vertical component must point upwards. The reason for that is that this arrow is going left and up. That's why horizontal goes left, vertical goes up. The directions are very important. Now, what did we learn? That the component opposite to the theta is the sine component. So the hypotenuse stays the same. This is 50. So you write 50 sine 25. And this will be 50 cos 25. Okay. Any questions so far?
No.
Okay. Now I'm going to ask you to resolve these four forces in your notes, in your notebooks. Okay. Here's a force acting in this direction, making an angle of 10 degrees, or let's call it 60 degrees. Okay. And this is a 20 Newton force. Resolve the components. Then here's another one going in this direction, making an angle of, let's say, 45 degree with the horizontal. And this force is a 30 Newton force. Resolve its component. Another one, this direction, making an angle of 10 degrees with the horizontal, and the force is of 40 newtons. Okay, then 50 Newton force acting at 70 degree angle with the horizontal. Break these forces into vertical and horizontal components. And mark the arrows on the components as well. When you're done, send me the picture. वेटिंग फॉर द पिक्चर्स, अभी तक कोई आई नहीं। Done. Shouldn't take you this long. Do not find the values of the,
Ma'am, that's wrong.
write them in the form of sine and cos. Okay.
Ma'am, last वाला 70 and
70 degree, 50 newtons. Daud and Alia, are you doing this?
Yes, ma'am.
No pictures received so far. फिर इतना टाइम लग रहा है तो इसका मतलब इतना अच्छा समझ नहीं आया। आलिया एक डायरेक्शन गलत बनाई हुई है सेकंड वाले की। अगर ये एरो डाउनवर्ड्स जा रहा है तो ये लेफ्ट कैसे जा रहा है? ये तो राइट जा रहा है और फिर नीचे जा रहा है। एरो ठीक करो। नहीं
Ma'am, did I send you something?
आयशा, नहीं नहीं सॉरी, आई मेंट आयशा, नॉट आलिया, सॉरी। आयशा, मुझे ये इस थर्ड वाले का भी की एरो नहीं समझ आ रही है। एक तो अपवर्ड्स है और फिर जो आपका हॉरिजॉन्टल कंपोनेंट है वो उसका आपने एरो गलत बनाया। देखो, दिस एरो इज गोइंग in this direction, that means it's going left and up, so ये left होना चाहिए। इसी तरह इसकी भी, इसकी एरो अगर ये इस डायरेक्शन में जा रहा है तो मतलब कि लेफ्ट जा रहा है और डाउन जा रहा है। ठीक है, सो लेफ्ट एंड डाउन। एरोज अपनी ठीक कर लो, कंपोनेंट्स आपके ठीक है। बट अगर एरोज गलत बनी तो फिर क्वेश्चन गलत हो जाएगा, क्योंकि आप फॉरवर्ड फोर्स को बैकवर्ड कर दोगी और बैकवर्ड को फॉरवर्ड कर दोगी। बाकी आपका ठीक है। ओके, नाउ आई एम चेकिंग अजर्स। दाऊद आया नहीं अभी तक।
मैम अभी भेज दो।
अजहर ने तो ऐसा ब्लर भेजा है कि मुझे अपने लेजर पे शक होने लग गया। मेरे साथ
मैम एक और भेजा था।
स्कैम हो गया। नहीं बस ठीक है, हो रहा है गुजारा। ठीक है सर, सारे ठीक है, गुड जॉब। आलिया, वाओ, दिस इज सो टेक्नो आलिया। एक्स वाई एक्स, अच्छा फर्स्ट वाले की डायरेक्शन गलत है आलिया, देखो योर एक्स इज पॉइंटिंग इन द रॉन्ग
Oh, X
डायरेक्शन।
is going the other way. X is going
यार,
the other way. My bad.
ठीक है। अच्छा, सिमिलरली रीचेक द डायरेक्शंस ऑफ पार्ट डी, व्हाट्स ऑफ अबाउट इट?
मैम डायरेक्शंस भी साथ करना।
X is supposed to go the other way, and then it's Y is going down.
हाँ सही, आप सही है। हाँ जी, डायरेक्शन बहुत इंपॉर्टेंट है कि एक्स की डायरेक्शन राइट है कि लेफ्ट है, और वाई की अप है या डाउन है। दाऊद डायरेक्शंस के साथ भेजो मुझे। बाकी ठीक है आलिया, तो टू डायरेक्शंस वर इनकरेक्ट। ओके, एंड दाऊद अब दोबारा भेज रहे डायरेक्शन के साथ।
जी मैम।
और दाऊद ये नहीं सही किया आपने, एक्स और वाई बनाए ही नहीं है कंपोनेंट्स आपने।
मैम मैं एक मिनट पूरा दोबारा करके भेजता हूँ।
हाँ, आपने एक्स कंपोनेंट बताना है क्या है, वाई कंपोनेंट बताना है क्या है। मैं करा दूं बोर्ड पे जल्दी से, मुझे नहीं लगता आपको
मैम मैम ठीक है मैम,
सम...
करा देंगे दफा फिर।
हाँ, ये जो
वैसे
एक,
सर ने बहुत प्रैक्टिस कराई है इसकी।
तो फिर सही क्यों नहीं की? सर ने प्रैक्टिस कराई हुई है, एक भी नहीं सही करके भेजा। एक्स का कंपोनेंट नहीं बनाया, वाई का कंपोनेंट नहीं बनाया आपने, बस रैंडमली किसी के साथ एक्स लिख दिया, किसी के साथ वाई लिख दिया। तो अब ये देखो क्या करना है। ठीक है, ये ऑपोजिट जो होता है ना, ये वाला हमेशा साइन का कंपोनेंट होता है। इसके साथ लिख लिया साइन 60, और इससे पहले 20 लिख दिया, 20 साइन 60। और ये जो नीचे वाला कंपोनेंट होता है जो 90 डिग्री और एंगल के साथ होता है, वो हो गया 20, हमेशा कॉस का कंपोनेंट होता है, कॉस 60। ठीक है, और एरोस किस तरह लगती हैं? ये इस डायरेक्शन में जा रहा है, तो इस, ये राइट जा रहा है और ऊपर जा रहा है, सो इधर राइट और इधर अप। समझ आया दाऊद?
जी मैम। मैम दोनों साइड्स की देनी थी, एक तो जो लेबल नहीं हुई और दूसरा जो बनानी थी।
समझ नहीं आई आपकी बात दाऊद।
मैम एक तो अभी जो आपने नीचे 20 cos 60 लिखा है, ये वाला भी फाइंड आउट करना था।
हाँ, एक्स और वाई कंपोनेंट दोनों करना होता है ना आपकी को, एक जो भी एंगुलर फोर्स है एक एंगल पे है, उसका एक एक्स कंपोनेंट बनता है और एक वाई कंपोनेंट।
ठीक है।
अच्छा, व्हाट अबाउट दिस वन, ये कंपोनेंट क्या होगा और किस डायरेक्शन में होगा जो अभी बनाया मैंने?
मैम डायरेक्शन तो नीचे की तरफ ही होगी, और 30 cos 45 होगा, और दूसरा वाला
नहीं
होगा
नहीं नहीं नहीं
ऊपर
नहीं,
वाला
ये
जो है
ऑपोजिट है। ऑपोजिट वाला कंपोनेंट होता है साइन, जो एंगल के ऑपोजिट होता है ना वो
30
हमेशा।
sin 45।
हाँ, साइन 45। और ये वाला हॉरिजॉन्टल कंपोनेंट,
ये साइन ये कॉस हो जाएगा।
हाँ, तो 30 cos 45, और इसकी डायरेक्शन किधर होगी?
आ, इसकी राइट साइड पर जाएगी।
हम्म, ओके। अच्छा जी, इसमें अब पहले ये बताओ, ये कंपोनेंट।
ये 40 cos 10 होगा।
ठीक है, बिल्कुल। डायरेक्शन
डायरेक्शन लेफ्ट साइड पे जा रहा है।
सही है। और ये बताओ,
ये होगा 40 sine 10.
ठीक है, डायरेक्शन
डायरेक्शन ऊपर की तरफ होगी।
अपवर्ड होगी। ठीक है, चलो अब लास्ट वाला खुद कर लेना, आपको समझ आ गई है, गुड। अच्छा, अब वापस इस पे आते हैं जो मैंने फर्स्ट क्वेश्चन कराया था। उसमें क्या था, ये 30 था ना, तो 30 के ऑपोजिट कंपोनेंट हमने देखा था, दैट वाज 30 साइन 20। ठीक है, अब ये आपने फिगर में किधर बनाना है, फिगर में ना यू गोइंग टू पॉइंट इट अपवर्ड्स, क्योंकि ये वर्टिकल कंपोनेंट है, सो यू कैन जस्ट पॉइंट इट अपवर्ड्स 30। एक सेकंड, this is going to be 13, so sin 20 pointing upwards, और राइट साइड पे पॉइंट कर दिया हॉरिजॉन्टल कंपोनेंट 30 cos 60, कौन सा एंगल था, 20। अच्छा, अब इसका क्वेश्चन देखते हैं किस तरह से आता है। ओके, अच्छा क्वेश्चन है कि a van of mass 750 kg is being towed along the horizontal road with a constant acceleration 0.8 meters per second square by a breakdown vehicle. Okay, so there's a 750 kgs weighing van. Okay, the acceleration is 0.8 meters per second square. We'll use it when we use forward minus backward Newton's second law. Is being towed by a breakdown vehicle. So let's say it's being towed in this direction. The connecting tow bar is inclined at 40 degree to the horizontal. So that means the force towing it is in this direction, obviously in the direction of motion, and it's making a 40-degree angle with the horizontal. So that shows that there's an inclined force. So there's going to be tension in that string, but you're not going to take that tension directly in the working. You're going to resolve it in its vertical, into its vertical and horizontal components. Given that the tension in the tow bar has a magnitude of 1000 newtons. So this is 1000 newtons. Okay, before we move on, I want to resolve this. So this component, the upward component, which is actually here, but I'm not drawing it here, I'm drawing it on the figure. So I think I should draw it at the center. So this is going to be what? This component, what should it be?
1000 sine 40 degree.
Bilkul sahi. 1000 sine 40. You may also draw it here, but I'm drawing it at the center. So 40, sorry, 1000 sine 40. Okay, so there's an upward force of 1000 sine 40, and the horizontal component will be pointing right. What's going to be its magnitude?
1000 cos 40.
Yes, 1000 cos 40. So now you're not going to take this force. Instead, you're going to consider its vertical component and horizontal component. I'm still going to keep it in the figure, but we won't be using this inclined force. Okay. Next, it says given that the tension that has been accounted for, calculate the magnitude of the force resisting the motion of the car. So there is a resisting force. Where should the resisting force point? There's a force of
Backward.
Hanji,
To the
backward.
left?
Yes, to the left. Here, let's call it resisting force FR. Okay, force of resistance. Okay, and we have to find its value. Okay. Yeah. So how do I find this resisting force?
Forward force minus backward force is equals to ma.
Exactly. So what's going to be the forward force?
1000 cos 40.
Yes. This in reference to this is the forward force because they're both in the same direction. So to find the frictional force, you're only looking at the horizontal components. You don't need the vertical components. So forward force is going to be 1000 cos 40. What about the backward force?
F1.
Yeah, the force of friction.
F1.
Take it. Equals, we know the mass 750, we know the acceleration 0.8. Find the frictional force, please.
$166.04.
Okay. 166.04 newtons. Is it an exact value or do you get more decimal places after that? I think.
You get more decimal places after that.
So that means it's a non-exact answer, which has to be rounded to 3 significant figures. To 166. Okay, that's the frictional force. Okay. I'm going to add something to the question because usually in the past paper, the question does not end here. It might also say, find the force resisting the motion of the car and normal contact force on the car. You also have to find the normal contact force. Okay. Who can tell me what direction is the normal contact force in?
One 1000 sine 40. That's the normal contact force.
No, that's not the normal
Upwards.
contact force. It's the force because it's the vertical component of the tension. That's not the normal contact force. There is a normal contact force, which you also have to point upwards. So there is a normal contact force. Ye hogi. It's acting upwards as well. R. अच्छा अब दो forces ऊपर act कर रही हैं. One is the normal contact force. One is because of the tension, because the tension has a vertical component as well, which is 1000 sine 40. This car is not going to fly upwards into the air, even though there are two forces acting vertically upwards. Why is that? ये गाड़ी उड़ के ऊपर की तरफ क्यों नहीं जा रही? What's the force that's balancing these forces? कुछ downwards भी होना चाहिए. Exactly, weight. हाँ, weight. So नीचे भी एक force है, which is the weight, which is balancing these two. So now you're going to equate the upward forces with the downward forces. This is mg, which is 750 times 10. So that's 7500 newtons. Okay. So now the other equation you're going to use is forces upwards equals forces downwards. Okay, you can write F up equals F down. There's no MA in this case because there's no motion in the vertical direction. The motion is in horizontal direction. Up and down forces totally cancel each other out. Okay, so it's going to be R plus 1000 sine 40 equals 7500. So please find the value of R. What do we get? Find R, you subtract these two.
6,857.21.
21. So you may round it off. 6, 8, 6, 0 in 3 significant figures. Okay, more questions? Okay. So the next question is, a car of mass 850 kg is being pushed along a level road with a force of magnitude T Newton directed upwards at 25 degree to the horizontal and also is also pulled by a horizontal force of 283 newtons. Okay, there's a constant force of 600 Newton opposing the motion. The car is moving at a constant speed. So constant speed mein hame pata hai, acceleration is 0. That means forward force equals backward force. Find the tension and the total normal contact force from the road. Okay, I want you guys to make the figure and send me the picture. जिस तरह अभी मैंने पीछे बनाया है, एक कार बनाई है, फिर उस पे इंक्लाइन फोर्स बनाई है, फिर उसके कंपोनेंट्स बनाए हैं, फिर वेट बनाया है, फिर नॉर्मल कांटेक्ट फोर्स बनाया है, फिर रेजिस्टेंस बनाई है, वो सारी फिगर पे शो करो एंड सेंड मी द पिक्चर. ये मैं ग्रुप में भी भेज देती हूँ क्वेश्चन, बल्कि आई एम सेंडिंग यू अ न्यू लिंक, सो प्लीज जॉइन अगेन. आई एम एंडिंग दिस वन.